I hope you are having a great droidcon. I am Saket. I work with Uncommon far, far away in Bangalore, India. We are a small team of 20 people who specialize in building and designing applications for companies of all shapes and sizes. I'm sure most of us here are already familiar with spans, but I feel that the familiarity of using spans is mostly limited to styling of text. However, spans are capable of doing much more. I like to compare spans with air in Android. Just like how air is all around us and we rarely notice it, spans are also heavily used across the platform and we hardly notice their existence. There is an easy way to find this out, an easy way to discover the variety of spans in Android. For instance, let's make an edit text and then enter some text in it. The getText method on the edit text returns an editable object. This object can tell us about all the spans that are present inside the text. Let's iterate over them and print to logcat. We'll find that in just those two words, there are so many spans already present inside the text. There are some spans inserted by the keyboard, some by the spell check system, and many more. This is what we are going to explore in my talk. We will explore how they are used across the platform by Android for things apart from just styling text. And then we'll later also see how we can use spans for doing some very interesting things. Before we begin, let's have a small quiz about spans. I hope everyone is ready for this. I've got 4 questions here. 4 potential ways of showing text with HTML tags on a text view. And your job will be to answer whether those HTML tags will show up or not. So as the first question, we've got a string with bold, italics, and underline HTML tags. And we're passing its resource ID to TextView.setText. Your job is to guess whether the HTML styling will show up or not. That is, which one of these two outputs is the correct one, left or right. Again, we have a string with HTML tags, and we are going to show it on a text view by calling setText on it. Okay, so show of hands for people who think that the left output is the correct one. Show of hands, please. Okay, and hands for the right option. Oh, that's a lot. Okay, the left option is the correct one. The HTML tags do show up. Okay. Now, what if we use getString instead of directly passing the resource ID to setText? Do you think that the HTML styling will show up this time? Show of hands for left, please. The left option? No one? I'm guessing everyone is voting for the right option then. Okay, you are correct this time. Now, what if we further wrap the getString call with an HTML.fromHTML call? What happens this time? Will the tags show up? Hands for the left option, and for the right option. There are some people who are not raising their hands at all. There is no third option. They do not show up. Okay, finally, apart from the HTML.fromHTML call, we will also wrap the string with a CData section. For those unaware, CData sections are used for escaping blocks of text that may be otherwise passed as markup. Do you think they will show up this time? Will the HTML show up? Show of hands for the left option. And for the right option? Are you sure? The left one is the correct one. Okay, so is there anyone who got all the options correct? One? I see one hand. Excellent, congratulations. Well, you are in the right place then. Okay, what is happening? Why are the HTML tags not showing up in 2 of those 4 situations? So the answer for this question lies in the source of getString. If we look inside, we'll find that getString internally calls getText, which in turn passes HTML blocks and converts them into spans, and finally constructs an instance of a span string out of it. But hold on, what is this new thing called span string? So to understand this, let's have a look at the class at the class hierarchy of char sequence. Similar to how string is an implementation of char sequence, there are other variations of char sequences as well. There's a sub-interface called span, and unlike string that can only hold text, span can hold both text and spans. The class that implements span is called span string, and this is exactly what getText uses to store both text and markup spans. There's also a mutable version of span called spannable, and the class that implements it, it's called spannable string. Now back to getText. Once getString receives the span string object by getText, it calls toString on it. This results in the conversion of span string to string, essentially discarding all the spans inside. This is exactly why the HTML tags were not showing up in two of those situations. The reason CData section work is because it indicates getText to not pass any markup. That is, to not replace any HTML with spans and return them as it is. I just realized that I might be the only person not using Kotlin in my slides. I'm yet to start with Kotlin, so I'm guessing I'm the odd one out this year. Anyway, who wants to use a well-designed modern language, right? Okay, so now that we have some understanding of when not to use getString and how the char sequence class hierarchy looks like, let's move on to the third part of this talk, where we'll try forming a definition of spans. A basic definition of spans would be that spans are markup objects that let you apply styling to sections of text. So for instance, if you want to display this text, what the HTML, where we want the word what in bold, the should be in italics, and HTML should be underlined. The code for applying this styling would somewhat look like this, where we apply a bold span to the first section, italic span to the second section, and underline span to the third section. Or if you want to save ourselves from the pain of dealing with indexes and the verbosity of spans, we can use something like Truss by jQuadrant. Truss is a small, useful library. In fact, it's not even a library, it's just the one class that makes it very easy to work with spans. It abstracts away all the headaches of dealing with indexes in the string. And there's nothing special about Truss. It's a really straightforward class, but it's one of those things that make you think, why did I not think of this? Now let's look at the source of spannable.setSpan. We'll notice that there is no base type for spans. The method setSpan can in fact take any type of objects, which means that we can put in random objects inside the text, random spans inside the text, and extract them later whenever we want to. Which further means that our original definition of spans, that they are only used for styling of text, was slightly incorrect. And maybe a better definition would be that spans are like a markup storage mechanism. That being said, please do not use spans as a replacement for your database. Additionally, spans can also overlap with each other, which means that we can have multiple styles applied on the same section of text. And they will appear at the same time. So for example, in this screenshot, we have an underline span and a foreground color span on the same word, that is width. In case the same type of spans are used, for example, if we apply a red background color span to a section of text, and then we apply another blue background color span on the same section of text, it will result in a blue color. that is, the last one will win. Spans can also move with text, and this behavior depends on the flag we supply to setSpan. There are 4 flags available: inclusive, 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 exclusive, 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 and exclusive, inclusive. Since I always get confused with these spans, I thought it would be a nice idea to explain them here. An easy way to understand the flag is to divide them into 2 parts. The first part controls whether the span will move to include changes made at the start position. Likewise, the second part controls whether the span will move to include changes made at the end position. I know this does not make enough sense right now, so let's have a look at some visual examples. For instance, if we use inclusive inclusive on a foreground color span on the word pickle, the color span will move to include changes made after after its end position. Likewise, it will also move to include new changes made at the start position. A good use case for this behavior is text editors like Google Docs or Dropbox Paper, where we want to, where once a user turns on bold, we want to keep any new text in bold until bold is turned off. In case of inclusive exclusive, any changes made at the end position will also get included. Sorry, will get excluded. But it will include changes made at the start position. Exclusive inclusive is the reverse. It will include changes made at the start position. So I'm sorry, at the end position, but will exclude changes made at the start position. So green stays in white color. It does not get included in the color span. The last flag, exclusive exclusive, is the simplest of all. It will not include any changes. So both Morty and green remain outside the color span. By the way, when we are using the term start and end, we are referring to the positions where a selection starts and ends. The start position may or may not always be the position on the left. And this is important because we can select text in both directions, left to right or right to left. Okay, so using these properties, Android uses spans for implementing a lot of things across the platform. The first example is text selection, where TextView inserts a span called selection_start into the text at the position where a selection starts, and another span called selection_end at the position where the selection ends. This lets TextView figure out what portion of the text to highlight, which is also why when we call methods like getSelectionStart and getSelectionEnd, TextView simply returns the position of the spans in the text instead of maintaining its own state. Blinking cursor is another example which is just a variation of text selection, where TextView shows a blinking cursor if both the spans, start and end, are at the same position. Even hyperlinks use spans. So Android uses this class called URL span for highlighting text and unhandling the clicks. Now the code for adding links to a text view looks somewhat like this, right? Let's see how this code works. HTML.from HTML replaces every HTML link it finds in the text with a URL span. And the link movement method behaves as a touch listener for those spans. So inside the touch listener, whenever it detects that a click was made on a span, it delegates the call to the spans onClick method, which in turn triggers a new intent with action_view for opening the link. And that's how hyperlinks work in Android. I mean, that's a brief overview of how hyperlinks work in Android. Yeah, let's look at another example. On external keyboards, Android keeps a track of meta key presses like caps lock, alt, etc. by inserting spans in the text. So and this is something you can try out on an emulator, where if you're pressing the shift key on your computer's keyboard and typing something, This class called meta_key_listener will insert a span called CAP in the text for signaling caps lock. Spell check also works using spans. Android inserts a span called spell check span every time it finds a spelling mistake. And TextView underlines the text contained within spell check span and shows a suggestion pop-up whenever those words are clicked. That brings us to the last part of the talk, where we will explore how we can use spans for doing some very interesting things. The first use case is animating letters in text. The idea is that since spans can access the TextViews paint object, and spans can control the styling of the text on a per letter basis, we can create some really nice animations by combining spans with object animator. For example, we can create this strike through animation. And in case you did not notice, that animation is running on the toolbar title. I really like animations keynote. So we can do this animation on the toolbar because animating spans does not require a reference to the text view. It only needs a reference to the cast sequence being used to set the title on the toolbar. The implementation for this animation is pretty straightforward. Here, we are setting the toolbar's title to an object called myText of type spanable, and setting it to the toolbar's title. Next, we create a strike-through span, and then using an object animator, we animate the length of the strike-through span from the first letter to the last letter of the text. At the end of every frame, we must also set this updated text to the toolbar's title. This has to be done because TextView does not listen to changes in the span, in its spans. It does not redraw itself whenever the spans are changed. So we have to force update the toolbar by calling set title again. Here's another example, another animation with a nice little typewriter effect. By the way, this is implemented using foreground color span, where we set the visibility of each letter sequentially using an object animator. We can also create this cool looking shimmer animation by using a custom span. And this time, in this span, we will set a gradient shader on the TextViews paint object. Rest everything is the same as the previous example, where we have a similar object animator, and on every frame of the animation, we offset the gradient by some pixels. Another use case where spans can be really useful is flattening layouts. In this hypothetical music app that happens to be very famous in Sweden, instead of using multiple text views for displaying text with varying styles, that is, they only vary in the font family or size or color, etc., we can replace them from mini text views to a single text view. And we can use spans instead. This efficiency may not matter in most of the cases, but if you're using a recycler view where each row has a very complex layout, yet reducing the number of views might give you a small performance boost. This is one of my favorite examples of spans. Similar to how Android uses spell check span for telling us about misspelled words, we can also provide our own suggestions to the text to the user by using a class known as suggestion span. In the screenshot, it's a sample reminder application that is using suggestion span to give other time options to the user. And here's how simple it is to build the example using suggestion span. So for every suggestion we want to show for a section of text, we insert a suggestion span in that section. And that's it. TextView handles doing everything else for us. It handles highlighting the words and showing suggestions pop up whenever the words are clicked. One last thing, I'm going to mention a small library I wrote called Better Link Movement Method. It fixes some of the flaws of the default link movement method provided by Android. It is designed to be a drop-in replacement for link movement method, so you can add it to your project in a very straightforward way. Just add the word better, and your project becomes better. The first thing that it offers is a simple way to listen to clicks and long presses on hyperlinks. This is something that is not offered out of the box by Android. A good use case for this can be handling phone numbers in your application, where instead of taking the user directly to the phone dialer when the phone number is clicked, you might want to offer options like calling the number or sending an SMS or saving it to contacts, etc. Apart from that, it also tries to fix two very annoying issues with link movement method. The first one is its incorrect calculation of touch areas. And as you can see in this video, if a link is present at the edge of text, the default link movement method registers clicks even if they are made outside the bounds of the link. The second issue is unreliable highlighting of text of links, where highlighting regularly stops working after the first click. In comparison, here is Better Link Movement method in action, which registers clicks only if they're actually made on the links, that is, if they're actually made within the bounds of the links, and it always highlights focus links. I'm not sure about you, but I used to see these problems in all the applications. It's been there for many years now. I'm not sure if it's intentional, but I chose to fix them for my own personal library, personal application, and decided to open source the library. Here's a quick reference to Jake's Trust class and a talk by Chuki-chan, which you should really watch. In the talk, she walks through the usages of spans, mostly framework spans that are provided out of the box by Android. And that's all. Thank you for attending this short talk on spans.